to be a life member at Omdena, so that's that. Amaan is an IT undergrad and a lead ML engineer at Omdena. He has worked as an ML research engineer at Unreal AI, and currently he is working as an ML and automation intern at Chubb. So that's what we have in store for us. And I think for the next 1 hour, we're going to be leaving it up to you people. So you can take it forward, Lucie.
Sounds good. Thanks for the introduction. We're really happy here today to be able to present to you guys and see how you guys can get involved, as well as give a little bit of information on the work that we do. So that's what Juber and Mohammad are going to talk about today. So hope you guys enjoy it. I'll just start with a little introduction to Omdena, the motivation behind Omdena, what we are as a platform, and then how you can get involved and kind of the benefits of being involved with us. And then I'll hand it over to Juber and Mohammad, and then we'll follow with a Q&A session where you guys can ask questions that you see fit. So I'm going to share my screen. I hope everyone can see it. Narayan, can you confirm?
Yes, absolutely. We can see that.
Great. So just to give a quick overview, what we are as a platform. So we are a bottom-up AI collaborative development platform. And the motivation behind Omdena, so we were founded almost 2 years ago, so May 2019. And the motivation behind Omdena was one, to tap into the global talent pool that now has access to education, opportunities, and knowledge. So tap into that global talent pool around the world. Because it's now accessible and the people have access to knowledge, leverage that global talent tool to solve impactful and important problems that we're facing today. Because in order to solve those problems, the most pressing problems that we have, we need all of the people from all over the world. And then finally, to use the people to solve the problems in a collaborative way. So sorry, I was just letting people in. We're very much, we believe in collaboration over competition. So there's so much competition out there, but we believe the best solutions are built through using collaboration and doing so by involving people from all over the world. So where are we now? We, as a platform, partner with organizations from all over the world, large, small, public, private, who are solving impactful problems in this world. We partner with them. And then we get together global teams of 40 to 60 people to work on the problems in the form of a project or a challenge in order to deliver ethical and efficient solutions. So right now, we've done, actually on Thursday, we're gonna be kicking off our 50th project. So right now we're involved with 49 projects. On Thursday, we'll be kicking off the 50th. We have over 1,700 AI and machine learning engineers who've collaborated on our platform from 88 countries all over the world. So that's what we are as a platform. And what does that look like? So what is our representation? So right now we have 35 to 40% of our lead engineers are women. We have representation from all different continents, different countries in the world that you can see on the slide. The people who collaborate with us come from various levels of experiences and backgrounds, age groups typically from 17 to 65 years old. And then, of course, years of experience ranges from anywhere from 1 to 7+ years of experience in machine learning, data science, AI. And yeah, so the purpose of us being here today and presenting to you guys is because, you know, as I had a conversation with Narayan about Plaksha, you guys are super focused on technology, different forms of education, and providing access to your community of students to global organizations around the world who are also focused on solving these types of tech-related problems. So that's a little bit about the platform. Now, you know, how do you apply to our platform, or how our project hosted on our platform? So if you look at our website, and I'll make sure to share the link afterwards, we have all of our upcoming projects on our website. Currently, we're starting a new project every week. So you will be able to apply to projects every week. ranging from NLP, computer vision, to predictive modeling, and any other type of domain that you can think of, we pretty much have on our website or have completed in the past. So looking forward to seeing you guys on some of our challenges. And before I hand it off to Juber and Mohammad to go over two of our use cases, so they're going to talk about the projects that they've worked on, the results, how they collaborated on our platform, and what they got out of it. I want to show you more holistically what it means to be part of our community. And so this is on our website as well. I'll share the link as well, but this is just an overview of how our community is structured. And what that means is, you know, the projects that I just showed you guys and talked about is, in order to join the community, the Omdena community, you have to complete one of those challenges. And if you look close enough here in the depiction that we have, sorry, I'm just letting people in still. If you look close enough here in the depiction that we have, you'll notice that our community is structured in a way that really focuses on your personal and professional development. So you join as a collaborator. If you actively participate in a challenge and you complete a challenge with us, then you join the community as an associate member. And that's where you start receiving opportunities from the community based on your contribution as well as your collaboration within our challenges. So it starts with us, you know, providing you access to courses like Data Camp. We have a partnership with organizations like Data Camp to provide skill development courses to our community. We also work on personal branding and development. We highlight you on our social medias. We help you write articles through Omdena and publish them. And then once you complete more challenges with us, you become a life member, an ambassador, we provide more of those types of opportunities, like you know, you can start working on paid projects, data science projects that we offer the community. We also get invited to international conferences or host demo days that we invite you to be speakers at. And then finally, when you're an ambassador, we also have just launched a career services, actually, where you know, based on the development, the place you are in your career, the development path, you know, some of you guys are less technical, some of you are more technical, depending on where you want to go. We provide you with career services to match you with the right people, opportunities within our network, as well as within our community, to get you there and where you want to be. So that's kind of an idea of how our community is structured, and we're really intentional about it to make sure that we're focused on what it is that we can provide to you and what it means to be part of the community. So I think I don't want to take up too much more time, because I'm excited to get into Mohammad and Juber's presentations. So I'm going to hand it over to you guys to take it over.
So maybe I will go first.
Yes, go ahead.
Can you please enable the screen sharing?
Okay, done.
So hopefully you guys see my screen, right?
Yes, today we can see your screen.
Okay, so before going into the technical part, let me first talk about the journey I had in data science. As Narayan mentioned already about me, that I'm actually an engineer. And I was born in Bangladesh, in Sylhet, which is at the very border of India. And I also had the privilege or opportunity to visit India, starting from Kolkata all along the way to Mumbai, Chennai, and some other cities. So I was born in Sylhet, and I grew up in a rural setting. So this is the picture in the middle, in the first row, actually taken from my area. So you can see the natural beauty, landscape, But of course we had, I mean, still now we don't have very good infrastructure, and I had limited access to electricity when I was a child. This is not my picture, but the third picture, a boy is, studying under lantern. So actually my childhood study environment was almost like this. Because we had limited access to electricity most of the time, we had to study under kerosene lantern. Yeah, but I had one big advantage, and that was my parents. My father was a school teacher, my mother, she was a health worker, and both of them, they helped me to dream big. So they are the one who planted in me the idea of dreaming big, dreaming to become a scientist from the very childhood. And I'm very happy to share with you that today I am a professional data scientist in the USA. And I would encourage everyone to dream big. One day you will achieve it. And I would like to recognize all the alma maters that helped me to achieve this position. And it's all started with Bangladesh University of Engineering and Technology, which is a top university in Bangladesh. In terms of engineering, it's the ranked one university. So I did my undergrad over there, and after that I moved to the United States for a PhD at the University of Memphis. So the second picture is from the University of Memphis in Tennessee, USA. So when I started my PhD program, I took some courses in artificial intelligence, machine learning, data science, and I got an internship at Samsung Research America in Mountain View, which is the headquarters of Google. And you know that Samsung uses Android in their operating system, smartphone. So we have a very close collaboration with Google. So this is the time when I actually realized that academic projects, whatever I have done, is not really good enough to start as a data scientist in the industry environment. And I was like trying to connect with professionals on LinkedIn. And this is when I actually got connected with Rudradev, who is the founder of Omdena. And I applied for a project, and he accepted my application, offered me a machine learning engineer position at Omdena. And I started with Omdena as a machine learning engineer. I worked for Omdena almost for 1 year. And at the end of 1 year, I got this data scientist position full-time at FedEx, which is the top 50 company in the whole world. So I will discuss what I learned from Omdena and what I did over there. And this is the very first project that I did for Omdena. And later I did more projects which involves computer vision, natural language processing, and other techniques. But this is the very first one that I did for Omdena. So the problem was that we all suffer from, I mean, especially in India, Bangladesh, and other countries in the Asia Pacific. Almost every year we see a lot of cyclones, natural disasters, and other calamities. I mean, maybe last year, Cyclone Amaan, which was there and affected Kolkata very much. So the project was, or the aim was, how to estimate the impact of a cyclone or natural disaster beforehand. And this is very important for the supply chain. So if you would like to plan a very well-organized supply chain, you have to beforehand estimate the impact. Say a cyclone will impact or make, say, 20,000 people homeless, shelterless, and they need food, drink, other necessities. And the estimation is like for 10,000, then 10,000 people will starve or they will suffer from crisis. And if you have an estimation of 50,000, then the remaining 30,000, the foods, commodities, and other products will be wasted. So either way, if it is overestimation, this is not good. If it is underestimation, this is also not good. So before it was like based on domain knowledge, people try to estimate, but most of the cases we see either underestimation or overestimation. So this project Omdena initiated, and this is a very beauty from Omdena, that Omdena is trying to apply artificial intelligence in so many cases that people even don't think that we can use artificial intelligence or machine learning to solve this problem. Whenever we think of artificial intelligence, mostly we think of Transformer movies, some robots and all this. Yeah, these are part of artificial intelligence, but not the only case. We can use artificial intelligence for so many social good and other use cases. So this is a complex use case, and this is very important actually to become a real world data scientist, that you don't have a curated data set. You don't even know what is the solution to this problem. What you only know is about the problem. So the problem, we know that every year cyclone is coming up, hitting different areas of the world, starting from Japan, India, up to United States, especially Florida and other coastal areas. And people are getting died, people are getting homeless, shelterless. How we can help? So we will know the problem, but we don't have any data set, and we don't have any well-defined solution, because even in the scientific environment, this is a less studied case. So when you do the literature review, you don't really find much help. So we started actually gathering data and identifying the sources that we can use to develop a initial model. And then we planned our solution. So we decided that whatever solution we would have will be split into two stages. In the first stage, we will determine how many people will be affected. And here you have to keep in mind that number of people exposed is not the number of people affected. Most of the cases when weather agencies, they warn us about a cyclone, they predict number of people that will be exposed, but not everyone exposed will be affected. There are many factors I will discuss how there's a distinguishment between the two. And once we have the number of affected people determined, the second part is estimating the commodities we need. And we should estimate the need of the commodities based on the World Health Organization guideline, so that minimum nutrition is provided. It's not just I put some rice, lentil, anything, and we don't really follow. So there is like optimization. You have a target variable, you have some constraints, and you want to maximize your objective function. So I will discuss about this optimization a little bit. So the sources we identified are IB tracks, which tracks every cyclone in the world and every 6 hours. So they have the cyclone related properties like the strength of the cyclone, wind speed, or the latitude, longitude, and some other properties. Then we have MDAT, which has historical data for the past cyclones, almost 100 years of historical data. And then we got socioeconomic factors from the World Bank. Why it's important? Because if a cyclone with same strength hit Kerala in India, the impact will not be same if it hits Florida in the United States, because of the socioeconomic differences, the differences in the infrastructure and the housing. So we have to take into consideration this. And we have then the gridded population of the world, so that we have an idea about the population density, and we first can estimate the number of people that will be exposed. And then depending on different factors, we determine how many people will be affected. So this is a snapshot from the IB tracks data set. We see that they have information about the cyclone name, and there's the code. ISO is like an international code to identify different countries. And there is a unique identifier for the cyclone also. And then the basin, there are like 7 basins in the world, depending mainly on the oceans, like Indian Basin, the Atlantic Basin. And there are sub-basins. Say Bay of Bengal is a sub-basin in Indian Basin. And then the nature of the cyclone, there are different categories of the cyclone, and also the track. And then the time, latitude, longitude, and hours, like when the cyclone has been originated and the point it is reporting how many hours have been elapsed. So we have the cyclone properties, and some of the explanations are here, like DS stands for disturbance, TS for tropical. And this is a cyclone picture taken. So this IB tracks, they track every cyclone every 6 hours. So here you can see, like starting from the origin, it is tracking the cyclone every 6 hours up to the landing area. And this is the gridded population for the whole world. That is the second data set we had, like what is the population density. In some areas we see like the population density is higher, and in some areas we see the population density is lower. And then we had this exposed population. Based on the population density, we came up with this tabulation that if the cyclone hit this area, then if the radius is like 34 kilometer, if the radius is 50 kilometer, if the radius is 64 kilometer, based on the cyclone properties, how many people will be under the path of the cyclone. And based on that, we have like the exposed population by country. So if the cyclone with this sort of radial property hit this country, how many people will be exposed? And then we have these socioeconomic factors from the World Bank. And then from MDAT, we had the past history, like this cyclone with this sort of property, hit that country, how many people was actually affected, injured, dead. So we have the historical data from MDAT. So now that we have all the data sources, we joined the different data sources. And in joining, there was some challenges. Like for example, in IBTrex, you have the identifier for every cyclone, but in other data sources like MDAT, they don't have a unique identifier. So you may find different cyclones with the same name, in different years. So it's really hard to identify the exact cyclone that is available in IBTrex. So we had to actually merge the data sets based on 3 different columns. And in this way, we learned how to make effective or efficient merging of data sets. And then we had to scrape Wikipedia, we had to scrape different web sources, we had to scrape PDF. And this is something that I learned because like most of the time we work with tabular data set, we have a well-structured data set and we just start doing the machine learning. But in this project, most of our time was spent in preparing the data because you don't have the data. You have to collect the data from Wikipedia, you have to scrape the web pages, you have to scrape PDF reports, and which is like a different scale. It's not just running the machine learning model. And once we had the data set, the first thing we did was the exploratory data analysis. And this is very important. I would like to tell all of you that don't run into the machine learning model on the very first stage. You have to get some insight from the data, what it shows, what it means, before you actually start the modeling. So we started like exploring the data set that we finally made ourselves and tried to see the trends. So you see that here is the year-wise trend of different cyclones, how many cyclones are hitting the world every year. And then we have these cyclones by category. So if you look at the number of cyclones in each category, we see tropical cyclones are the most, which are actually the less impact cyclones, don't really create that much of problem. But we also have like high category, like category 3, category 5, which are really high impact cyclones. So, and then we see how many cyclones are generated each year from each basins. So as I told you, like there are different basins, Indian basins, Atlantic basins, Pacific basins, and in each, how many are generated every year. And then how many of them are actually doing the landfall and impacting people, how many people are getting impacted. So we had the pie chart. And then we tried to first determine the relation between the target variable. For us, the target variable was the impacted people, how many people was affected, and the different predictors we had, like the socioeconomic, cyclone properties, and others. And then we had a distribution of the target variable. You can see like it's almost normally distributed because we used log transformation. Initially it was skewed, but using log transformation, it was almost like a normally distributed. And then after some feature engineering, we got into the modeling part and we explored different models like random forest, support vector machine, neural network, and some other models. And this is the result we achieved. So we finally selected ensemble models, which is like a 2-stack layer. In the first stack, you have 3 different machine learning models like support vector machine, random forest, and extreme gradient boosting. And in the second layer, you combine the result of the 3. This is called ensemble of stack or stack of ensembles. And you see the result is almost like our prediction is very much superimposed on the actual. So the impact of actual and the prediction is very much similar. And we segregated it into different parts because we realized that the data target variable is not really, it's very sparse. So if you like use only one model to estimate, it's not a good estimation. So what we did is like we segregated in zones, and then for each of the category, we made a different estimation. And that's why it's almost really superimposed on the actual. And then the second part, we developed a Python tool, which is an application, Python application to automate the whole process. So you get the different sort of data right in the tool, and then it makes your job really easy. So how many people will be affected, how many of them are pregnant, and different sort of information. Once you fill up, you automatically get the amount of food commodities you need. And this is a very, useful tool that any agency can use. So the whole of this has been automated by this tool. Of course, we had some limitations. We spent 2 months, and there is still scope for improvements, like some other factors. It's not only cyclone that impacts how many people will be affected. There may be like other factors like flood risk, tsunami. There may be elevation differences and other properties, and there is some scope for improvement for that. And these are the data sources we used, and these are the collaborators who worked on this project. You can very much see that the collaborators are from the whole world, starting from United States, India, and some European countries, also some from African countries, Bangladesh. And here are the team. You see like from all races, Caucasian, African American, Asian American, and other people from other countries. Very nice team, and we made friends to all of them. And I'm very happy to see that a lot of them have become already professional data scientists, including me. And this is our facilitators. Here is Rudradev and our project manager. And on the right side, we see the World Food WFP, who helped us and sponsored or was a partner of the project. And that's all. And I invite everyone, please join Omdena. You'll learn a lot of real world data science, and that will help you transition into a professional data scientist position. Thank you very much.
Thank you, Juber. Before I get into Pragya for questions, how do you want to do it? Should we take questions for this presentation right now, or should we just take them towards the end? What is preferable?
I think maybe we should wait to the end, right? Or who was that question?
Yeah, I think at the end it will be better.
All right. Okay.
Thank you so much, Juber, for taking us along the challenge as well as the approach. This gives us a very close look of how climate change problems are approached using data science. Now we can go for questions. So if anybody has any questions about the approach, about Omdena, you can unmute yourself and ask.
Just one thing I want to add, we do have another presentation. Do you want to?
Yeah.
Oh, sure. So please go ahead.
So I'll be going ahead. Thank you. So guys, let me share my presentation. Okay, guys. First of all, hello everybody. I'm Mohammad Amaan. I'm also an IT undergraduate. I'm in my final semester right now. I'm from Kids Warangal, like a twin college to NIT Warangal. Not really deemed, but yeah, it's around. So I joined Omdena in March 2020 and April, around that time. And my first project was with Safe City. Actually, like the selection happened via Machine Learning India, which is quite popular on Instagram and also LinkedIn. So before I get into it, about me, I've been like from machine learning engineer to I've been promoted to a lead machine learning engineer at Omdena. And as a full time, I'm an ML and automation intern at Chubb. Before that, I was working at Unreal AI, which also supports the platform Docship. We actually built it, but then again, they had to move to Singapore, so I had to move to Chubb. It went well, and besides that, I'm also WorkFusion certified MLE. So WorkFusion is a company that automates machine learning flows in corporate scenarios. So that happened, like it helped me move from the Pythonic machine learning that we do, from like shifting my focus from completely ML to something the ML that can be incorporated into business logic. And prior to all this, I was really focused on Kaggle. I'm a 3-time expert there. I believe most of you can also get there and must have been beyond that, but Kaggle is really important. It's really good. Coming to the project, guys. This one, I've actually been in 4 projects at Omdena in total. This one, obviously, the Safe City project was my first one, like I told you earlier. Then I've been a part of Trash Out project where I did computer vision. Safe City was completely focused on NLP, but the rest of the projects, Trash Out, Solar AI, and Zap Malaria, these were all like mostly focused on computer vision. Coming to collaborators, like I have got a very long list of people I've collaborated throughout all these projects. So I've just highlighted some of them that I'm really close with right now, and like most of them, you can get a generalized view from this list here. That there has been an operations analyst from Google. She actually mentored me through this project and let me mentor this project when it started. And we also have PhD in astrophysics from Germany, a data engineer from Paris, and from India we have people. We have even people who like outperformed really well on Kaggle. And in the end, we have had plenty of students who got the chance to learn in the presence of all these people, me being one of them. Coming to this specific project by Safe City Foundation, the one who's hiring, like selection went through ML India. This one was with our partner Safe City Foundation, a Delhi-based company. This one was about uh, like analyzing domestic violence in India, mostly during the COVID phase. Uh, Domestic violence basically means violence or aggressive behavior within home. Mostly it's from a spouse or partner or somebody really close, and in rare, not rare, occasionally it's by people we are not related with. A headline from news18.com says every third woman in India suffered sexual or physical violence at home. So this must give you an idea of how severe of an issue this is, because most of the time it goes unsaid. So actually, this idea of this entire project originated from another project that was going on at Omdena. They really felt the need to carry out a whole new project to like tackle this problem. So when we started with that idea, we literally had no data. So this has been actually a great opportunity at Omdena, because most of the ML is garbage in, garbage out. So the better data you give, the better result you get, because the algorithms don't change. We only change what we give it to it. Give it give to it, sorry. Yeah, so when we started this project, we decided where will we be looking for the data. So our sources were mostly from news articles, Twitter, Reddit, and government websites, because these we felt can be kind of considered for real analysis. Obviously social media isn't completely reliable, but that's where we come in, right, to find the relevant and authentic data. So these datasets were prepared for the span of COVID-19 lockdown phase from 23rd March to 31st May of the previous year. Uh, then once we got the data by scraping through the websites and network, we started annotating it. The really crucial part of this project, we annotated it into these 4 classes: domestic violence story. This is when somebody in the article or tweet is expressing the domestic violence that they've suffered as a first person. And DV, domestic violence opinion info, is when somebody is giving some information which is in favor of domestic violence, sorry, against domestic violence, like the positive side where we tackle domestic violence. And advocate is a personal opinion in support of against domestic violence. And denier is a class in which all the articles and tweets say about, they deny the existence of domestic violence, telling this is a misleading article or tweet. So with these annotated data sets, we started building the machine learning models, mostly to classify which of these which of the articles belong to which of these fields. Then we also tag the data for NER, that is named entity recognition, to find out who was the victim and who was the attacker, and plenty of such fields, which I'll be showing you in the next slide. And to express this data, explain it completely to our partners and all the policy makers, we use Tableau. Uh, and most of them who didn't know Tableau in the collaborators learned it, one of them being me. And in the end, we were able to show this to our partners. So it was really great, guys, because Tableau it doesn't really come up when somebody talks about ML, but it's really important to have like visual results of the work you've done. So here I have two samples from our data. This is a news article. You can see it being more formal and straightway descriptive, but then again, it also requires huge lot of filtering. And then there is a tweet. Because tweets were extracted in a huge quantity compared to other networks like Reddit, which Indians aren't really much on. But again, our project was to analyze in India. So from this tweet, you can find it's really an informal way of saying, but it happens to be TV opinion advocate. Sorry, advocate or information. This must be a really tough call. I really put it in information because they are providing a helpline. So this was how we classified the data. And here are the word clouds that we've formed from our data. You can see most of the size of the words shows the frequency of their appearance across all the documents, all the articles and tweets. You can see words like police, sexual, wife, woman being in larger size, which says that females might be the victims in most of the cases, or they're involved in some sort of domestic violence. And based on the data set source, we put heat maps across the state map of India. You can see in both of them the intensely colored areas are the states of Uttar Pradesh and Maharashtra, and you can see small part of Delhi here being intense too, which is kind of complemented by the Twitter analysis too. However, you can see news articles say that Uttar Pradesh has huge, like larger cases of domestic violence. However, Twitter says Maharashtra. So this was backed by a thought that, by a fact, not just thought, that these metropolitan developed cities have a lot more access to internet. So people there are really outspoken with their situation, which is not the case with the cities that aren't as much developed. So when we looked at the state-wise government data, you can see Uttar Pradesh has many number of cases compared to other states like Delhi and Maharashtra. So you can see people might be figuring out, or you also know that literacy is little higher in this state. So people are aware of how to tackle domestic violence. Then again, it's not zero. So this cannot be neglected. However, the focus should be little larger amount of focus should be on these states which aren't as much developed as the others. This data is from Google Trends. It is a service that monitors all the Google searches. So we went with the keywords approach and key phrases approach, bigrams, trigrams, you call it. There was a separate team formed for this among our collaborators, and it really shows that you can see here Delhi being very high. So people are really Googling, like searching on the internet for solutions or maybe something related to domestic violence. Get it? So this one was for the key phrase women helpline time. So women helpline, sir, time is the scale. So you can see that people are coming out on this, but that's not the case with every state, right? And here, based on a certain type of report filed at the police, protection of women against DV cases, we put a forecast. This dark line of data shows the existing cases and which we forecasted to completely fit the original data. Uh, and here is the forecast, the lighter line. So obviously we cannot trust such a overfitting model, but then again, it's like it's good enough to trust the direction that it shows. Had it said it's going lower, like this case might not be that much of priority, but this says it's about to go high, and which we witnessed in the next months, not us, the partners. So these kind of forecasts were also helpful to determine if it is going to increase or are we doing well on stopping that kind of cases. Then the named entity recognition models helped us find the cause of domestic violence, under which circumstances domestic violence was happening. You can see here unknown reasons were a lot of them. Obviously, not all data can be tagged, right? So you can see false pretext, just some kind of misunderstanding led to domestic violence. COVID was also a reason in certain cases. Heated argument, you see refusal of other party, again misunderstanding. Affairs were also a cause of domestic violence. So all these insights really proved helpful to our partners. That like concludes our analysis. So we achieved the goal that we established with the start of this project. Uh, Coming to impact of this project, it has really shown us a large impact to an extent that our partner has taken this result to present in the Supreme Court of India, and with their support, they are tackling this issue. So it has really been a proud moment for all of us collaborators. And you see, the challenges that we faced in this were the data was really uncertain, and there was a lot of similarity between this data and the data for online harassment. Because if people are arguing on the internet, it's mostly not that serious. They might be hurt, like they might be serious about it, but they're not hurting anybody unless they come in physical contact. So it was because the words are really same, it was hard to distinguish. But then again, we leverage NLP to do that. The possible improvements we could have made or which can be made to this project were obviously more data. This is going to be the case in any data related project you go ahead with, and better technologies, because we didn't go for models that would be so as large as the transformers or what. We were like, it was also a learning opportunity for some of them, and some of them were using what they've learned. So also, because it should be scalable, we confined ourselves to the statistical model. So that concludes my presentation, guys. Thank you so much for having me.
Thank you, Amaan. The presentation has been very insightful. I think now that the presentation is done, we can open up for Q&A for both Juber and Amaan. If you have any questions, you can unmute yourself and ask.
So may I go ahead? I had a question for both the speakers. Hello?
Yes,
Yeah, sure, Shreyas, please go ahead.
So the first question I had was for Juber. So he mentioned that while explaining his project, he used the world population data. So the question was that how did they maintain the consistency in the year for which data was available? I mean, for some, and was it a state-wise world population, state-wise data for a country, or was it a nation-wise? Because for some nations, you may not really get the year you want, but a previous year data. So that would change the scale of when the data is being used, right?
Yeah, I mean, the question is actually very nice. What we did is we overlapped the path of the cyclone on the gridded population dataset. So there is, if you use GeoPandas or some other packages which are available open source, so you can actually superimpose these two. So what we did is like we got the track from the IB track, and then they have an estimation like the radius of the cyclone, how much will be like on both sides, and then we superimposed it on the gridded population data set. And from that, we have the actual area of the affected area. And then from there, we got the population density. It's not like a country or state, it's the area that will be under the cyclone. For that, we had the population density. So yeah, you are correct that if we take it for different years, it will be different. But for us, we just took the reference year when we worked like in 2019.
Okay, got it. And the other question was for the next speaker, in which he mentioned that he used annotation for data. But the question that I had was that how much time? What methods did they use? What methods did you specifically use for annotations, and how did you maintain the quality of the annotation of data, and how much time did it take overall for annotating? Because I don't think such form of data was readily available, right? So. Hello.
Hello, are you there,
It seems
Amaan?
like maybe he dropped, maybe his Wi-Fi didn't work. But I think Juber, he's participated in many of our projects. He can actually speak to that question for sure.
Yeah, what was the question again, please?
So my question was that he mentioned annotating the data for domestic violence. What methods did he use for annotating the data, and how much time did it take, and how did you verify whether the data that has been annotated was the quality of the data that has been annotated?
Yeah, actually.
Can I take it?
Yeah, sure.
Yeah, sorry, I just got disconnected. Okay, I get the question. It's about annotation, right? So we did have trouble with it. Actually, that was the most challenging part in the project, because ML models, we have most of them available. So we didn't actually implement anything there. We just use them out of the box. About annotation, first we scraped the data completely. We just had text everywhere. And that text we mapped to our context, first by classifying, annotating the classes for each document. We have this really helpful tool. What was that? Docano. Yes, Docano is an open source tool that helped us map classes to each document and also each entity. Like say, my name is Amaan. Amaan is a noun, so we can map it as a noun. Or we have a document describing some domestic violence incident. So who's the victim, who's the abuser, that we can map in it. Each word can be tagged with certain class. So we use Docano there, and analyzing this, like if the annotation is right or wrong. We had a guy named Tim. Yes, he really had good domain knowledge in this field. So the perk of having these many collaborators is people seem to have different vision, right? And the senior most guys, most of them, really have a proper understanding of this use case. So Tim was mostly in charge of QA, that is quality assurance. So we properly structured our annotation process to divide it among the collaborators, use Docano to tag the documents, and then we would be send it to Tim's team, where they would validate the annotation as a second check, so that the model isn't being fed some irrelevant data. So QA was the thing, the way we like validated the data.
Okay, got it. Thank you for the Q&A.
Now we have a question from Shreyansh, who typed in. He's asking about how the responsibilities are assigned to first-time collaborators in all these projects.
I think either of you guys can take that.
Yeah, so actually it's not a top-down approach that someone will tell you do this or don't do this, right? It's starting from you. So once you get exposed to the project, you have a good idea like what we have to do maybe in the first 1 week or 2 weeks, and then you identify your expertise area. So you are good in computer vision, you are good in natural language processing, or you have the good domain knowledge, or you know like how to do Python, you know how to do a web application, you know how to do a smartphone application, and you pick your area. So say, I'm good at smartphone application development. That's why I picked the Python tool development. I know software development. So then you say that I will do this, because it's like a collaborative approach. It's not like a competition that someone will say, oh, you have to do this. No. So you pick your chosen area and you're related with your expertise, and you start working on that, and you invite some others that let's do it together. So some other people will find similar minded, similar expertise. They will join hands with you, and you will start working on that. And then in the central weekly meeting, you discuss what improvements or what findings you have. So then they will maybe do some feedback, some suggestions, and it's like you drive the whole process. It's not like someone else will tell you do this or don't do that. That's how it works.
Also, to add to what Jubair said, in case you are like lost and you are unable to choose which team to join, not a different project teams that are working on certain aspects of the same project, there's always a chance to work in all of them, or you can learn from people who actually know that stuff. So like I said, Tableau, I wasn't really aware of it. And at Chubb, I'm like kind of helping people who are doing Tableau right now. So that really helps us. So you can even either go that way, or you can learn, you can just join to learn too and end up contributing.
Yeah, thank you, Amaan. Thank you, Jubair. Since you have a hard stop at 7:30, do you have 5 more minutes to spare to answer more questions which are coming up?
Sure. Yep.
Yeah, so Nudeep has his hand raised. So Nudeep, you can ask your question.
Yeah, hi everyone. My question is to Amaan. So domestic violence is something in most of the cases which is not recorded either. I mean, what I mean to say is people not always put this up on social media. News articles may come out or may not. So what is the validation for the progress which you have done in this project? So I'm keen on it.
Yeah, Anudeep. So about that, this was a concern raised during the discussions too. So we looked for in this kind of case, like the most reliable data we found was government reports. But then again, like you mentioned, not all of it comes to notice because people from really small cities might not even know there's a way to tackle this. So for that, we were mostly focusing on with this data, the partners had the idea to uh, like aim at the cities which are surrounded by cities which are experiencing most domestic violence, because those don't come into light. So we'll be going to that. So it was something like a decision of the policymakers, of the partners, that is the Red Dot Foundation. And we've come to know that they've actually started working on it. They've even launched a platform for this, which is again on mobile, might not be accessible to them, but it's a step towards it, towards a progress. So we also heard they are partnering with the police officials to work on this in a physical way. So our our data analysis was completely not pointing to small cities, but it helped us get there.
Awesome, got it. And Lucie, if you don't mind, I want to share my own experience with Omdena because I have personally worked for, 3 to 4 weeks, but I had to drop off from the project due to personal issues. So it might be helpful for the fellows to know about it, how collaboration happens there and all. Are you on mute?
Lucie, you're on mute, I think.
Oh yeah, sure. You can go ahead.
Yeah, I have worked on the project called Economic Wellbeing Modeling. So we were a team of 60 people. So this project was more related to satellite imagery data analysis and mapping on it with ground data. Ground truth data. So I was uh, I was not aware of much of those concepts, but as the problem statement was related to India, they wanted more collaborators from India. So yeah, I got interviewed by Rudraden, and yeah, uh, Google Earth Engine was a pretty new thing from where we extracted our data. I didn't know much about it, but due to the collaboration which we had over there, and uh, like collaborators giving inputs to us, we could manage, like, the learning curve was like exponential for me. Although I could not finish the project, but yeah, that was a great experience. I would recommend everyone to have a look at their projects, and yeah.
Right, thanks.
Yeah, thanks, Anudeep. As a follow-up question, there are other questions in the chat as well from Narayan, who's asking how we can apply for new projects as Plaksha fellows, and also how much technical know-how we need to have for that. So
yes, so given we're presenting to you guys, and we're building a relationship with you, we will be accepting applications from Plaksha University. So after this call, you guys will have a special referral code, or we'll give that to Narayan, and then whoever applies through Plaksha University will have the special code that that you guys will apply for, so that we can take those applications into consideration. And then when you talk about technical know-how, that was the other question. So as you guys gathered from these presentations, there's a distribution of experience on every one of our projects. There's people who are just starting out, there's people who are experts, and then there's people in between. So we want to make sure to keep it global, to keep it, with vast experiences, because, that's the way that we know AI solutions will be able to build ethically, as well as in the most efficient ways possible. So everybody is expected to have technical knowledge, technical backgrounds, experience working with technical projects, but how much experience really varies on the project, and also on the team of collaborators on a project.
yeah, that helps, Lucie. So we have more questions coming up about the team structure as well from Ankit Saurav. He would like to know how the team structure for an Omdena project is, and also understand the various roles which exist like in the project.
Mm-hmm.
And as a follow-up question to that, Mansi would also like to know about the average length of the project and how much time commitment we'll have to give. So,
okay. So I'll start with that one. Every one of our challenges runs for 2 months. So the commitment will always be over a 2-month period. And that's for every one of our projects. In terms of the, what was the second question? It was about the organization, right? Of the structure of the project. So Juber touched on this earlier. Since we're a bottom-up collaborative development platform, what that means is that there won't be any structure imposed on you. So there's a way, we obviously, in order to get a 2-month project to completion, we have our processes and our tools in place so that the project gets completed on time. However, the actual solution building and the technical aspects follow a similar pattern in every project. So the problem is broken down into various tasks, and then people take up those tasks or recommend those tasks. But there's no imposing tasks, there's no imposing roles or responsibilities